Dear students, good morning to you all. Today in this session, we'll learn about a BCD adder based on a flipped classroom pedagogy approach. Yesterday, I have passed you the presentation and the YouTube link for going through the process of BCD addition. Students, have you all gone through that? Yes, have you
Yes,
gone
ma'am.
through the text? Yes, okay, fine. Okay. Okay. So we'll have discussion upon your understanding what you have learned and all. We'll discuss. And when one of your friend is responding, others are kindly asked to listen to him, so that based on all the inputs that is gained, I'll finally explain you about the circuit that performs a BCD addition. Okay. So that is a plan for this session. And let me start with asking you a basic question. What is meant by a BCD code? Can anyone respond?
Uh, Binary coded decimal, in short, BCD is a way to represent each of the decimal digits with a binary code.
Yes, yes, fine, fine, okay, fine. Then how many digits are required to represent a BCD code?
In BCD, we require 4 bits to represent the 16 numbers from 0 to 15. In BCD, the
So whether
first
BCD is used to represent 0 to 15?
no, mama, we use only the first 10 combinations 0 to 9 to
Yes.
represent the BCD, and the remaining 6 code combinations are invalid in BCD.
Okay, fine, fine, fine. Okay, so you will be having only 0 to 9 binary code to represent 0 to 9, right? That is what your explanation is, Sharmini, right? Okay. Um, then, what is the difference between binary representation and BCD representation? Can anyone respond?
Actually, the main difference between the binary representation and BCD representation is in binary representation, the given number is represented in the form of 0 and 1. And in BCD representation, each digit of a decimal number is represented by a 4-bit binary number. For example, if we take decimal number 12, its binary representation is 1100, whereas its BCD representation is 0001 0010.
Yes, good, good. Okay. Students, have you all got this point? Yes. Binary representation of 12, as she said, it is 1100. Whereas in BCD representation, say if you're going to represent a number in BCD, a number may contain many digits, right? Each digit of the number should be represented with its 4-bit BCD equivalent. Okay, so that is what Chamila said. Thank you, Ma. And next question, I have passed the PPT, right? So I hope you have gone through the steps for performing the BCD addition. Can anyone respond the procedure for doing BCD addition, Ma?
Ma'am, we have to mainly follow 3 basic rules for BCD addition. The first one is if the sum is less than or equal to 9 and if there is no carry generated, then it is said to be a valid BCD digit. Next, if the sum is less than or equal to 9 and if there is a carry generated, then the sum is said to be invalid and the number 6 that is in binary will represent it as 0110 must be added to that digit. And if the sum is greater than 9, then the sum is said to be invalid and again 6 that is 0110 must be added to that digit.
Okay, that's good. Sneha, first of all, we have to represent the given number in BCD form. That is, each digit should be represented with its BCD equivalent. Then we have to perform a normal binary addition, right?
Yes, ma'am.
Yes. The result of the binary addition, we have to check the 3 conditions that you have explained.
Yes, ma'am.
Yes. Okay. So that is what Sneha explained about the rules for performing the BCD addition. So I repeat what she said. So if the first of all, we'll be writing each digit with its BCD equivalent. Okay, so 4-bit BCD equivalent. Then we'll perform the regular binary addition and it will be giving you a sum, right? So that sum should be lesser than or equal to 9. Means it is a valid BCD result. If suppose in other cases, like if it is greater than 9 or if it is less than 9 but produces a carry, that two cases, it is said to be invalid, and that invalid sum have to be corrected by adding a 6. Okay, so that is what the algorithm for BCD addition is. Okay, and the next question I have is, and what is the possible range of binary sums that comes out of the addition process? Say we'll do the normal binary addition first, right?
The
What is
range
the
of
yes, yes, Srinath, yes.
Yes, ma'am. The range of the resulting binary sum is from 0 to 19, ma'am.
Yes, okay. How it is a 19? Can you justify the point?
Yes, ma'am. By adding the BCD numbers, the resulting sum ranges from 0 to 18 by both adding both the questions and also the input carry. So the range of the resulting sum is from 0 to 19.
Yes, okay. So BCD, as you Srinath have told the point that the maximum binary sum that is possible is 19. So I'll repeat the point that you have justified. The maximum decimal is 9, right? So if I'm going to add two numbers, maximum possibility of a decimal is 9, right? So decimal digit, maximum digit is 9. So if you add a 9 plus 9 along with the input carry, it comes as 19. So the possible binary sum that results out of the first step addition that you're going to do, right? So it will be resulting in the sum within the range of 0 to 19, maximum of 19. Okay, so have you understand the point how it is 19? How do you tell that it is the maximum sum is 19? Students, can you understand or any doubts in this? May I get your response?
Understood, ma'am.
Thank you, ma'am. Okay. Then, next question I have is, out of the resulting binary sum, the 0 to 19, as Srinath said, okay, so which is said to be the valid result and which is invalid?
Ma'am, in a range of 0 to 19, we will call it as 0 to 9, we will call it as a valid sum. And
Yes.
from 10 to 19, we will call it as an invalid sum.
Very good, Venu. Okay, thank you. So, how do you correct if invalid sum, that is from 10 to 19, Venu Vittal told that it is an invalid sum, right? And it is right too. How do we correct it? And can you anyone explain about your idea about how to correct the invalid sum?
Yeah, ma'am. It can be corrected by adding the 4-bit by representation of a 6, that is a 0, 110 to a 9, ma'am. Because from 0 to 9, it is the base number for decimal, and after 9, from 10 to 15, it is a hexadecimal number. So if we are adding a 6 to it, that is a 0, 110 to 9, it becomes a 16 and above. So it becomes a valid binary number, binary decimal.
Okay, good Sridhar, good Sridhar. Okay, I'll repeat the point what Sridhar have explained. Okay, so up to 0 to 9, BCD is the exactly the code to represent the decimal digits from 0 to 9. Okay, so that is a decimal base is 10. So if it goes beyond 9, then we call it to then what is the next number system is a hexadecimal. Okay, so the difference between the bases, for hexadecimal the base is 16 and for decimal the base is 10. So the difference between the bases 16 minus 10, that is equal to 6. So that is why to adjust it to the correct sum, we need to add a 6 to the incorrect sum. What is it be the incorrect sum? That is also explained. Okay, so that 10 and above. Okay, so we told that possible range of sum that is possible is 0 to 19. 0 to 9 is valid sum. No need to do anything with that. That is correct result. And suppose if you get a binary sum in the range of 10 to 19, then you have to bring it to the right form by adding a 6. And why it is to be added with a 6, that Sridhar have explained. Okay. So very good students. Okay, so all of you I expect have gone through this, and all the other students also would have got the ideas that is shared by your friends. Okay, so now I'll share my screen to proceed further. So based on all the inputs that is being given, just a minute. It's loading, ma. Just wait. Yes, can you all see my screen? Students?
Yes, ma'am.
Okay. So, I have consolidated all the ideas that is being shared with you by the friends. Okay. So, what is a BCD code? A BCD is expanded as a binary coded decimal. Okay. So, it is a binary coded decimal, and it is a 4-bit code to represent the decimal digits from 0 to 9. Okay. So, 9 is the maximum decimal digit, and to represent a 9, minimum 4 bits is required. So, a BCD code is a 4-bit binary code. Okay. And the difference in BCD and binary representation, as Sharmila have explained, and I have given some examples. Okay. So, binary representation, let us take, I have given 2 examples here. Let us take the binary representation of 8. So, 8 in binary, it is represented as 1000. Okay, so in BCD representation of 8 is also 1000. Okay, so the binary and BCD representation of 0 to 9 will be one and the same. Okay, so that is to be understood from this point. Okay, so whatever is the binary value for 0 to 9, the same is the BCD representation for 0 to 9 also. So that is to be understood here. And let us take this example. What is a binary representation of a 10? Okay, so 10 in binary, it is represented as 1010. Whereas 10 in BCD, it is represented that each digit, 10 has 2 digits, right? A digit 1 and a digit 0. Each digit should be represented with its 4-bit binary equivalent, right? So could you understand the difference in representation between binary and BCD? Yes? Then we'll proceed to the next slide, where the rules of a BCD addition, as explained by Sneha, I have written here. Okay, so this is what we have to do for performing the BCD addition. Okay, so first of all, we have to write the BCD code for every digit of the addend and the augend. So what is it, addend and augend? Is, say, if I'm going to add two numbers, say if I'm adding two numbers A and B, so addend is A and augend is B. Okay, that is a name that is given to the numbers that we are going to add. So each digit of the number should be represented with its equivalent 4-digit binary code, that is BCD code. Okay, so then we have to perform the normal BCD addition, and in the BCD addition we'll get the possible sum as a 0 to 19, as Srinath have said, and then we have to check whether the binary sum is valid or not. Okay, so this is the main things that we have to do. After we do the checking, these are the main points that we have to do. Okay, so we had got a binary sum, right? So that will be one of the values from 0 to 19. In binary form it will be. Okay, and we have to check if the sum is lesser than or equal to 9, then and no carry is also there, then it is a valid sum. No need to worry about that and don't disturb it. Okay, it is a right result. Suppose if the sum is lesser than or equal to 9 and a carry is also produced, then we have to add a 6, and why that 6 have to be added is well explained by Sridhar. Okay, so that is the point. The second invalid case have to be corrected. The case 2 and case 3 are the invalid cases that have to be corrected. Okay, and if the sum is greater than 9, that is 10 and above, okay, means definitely that is incorrect. Okay, so we have to add a 6 and adjust it to the correct sum. Okay, so this is the process that have to be done, and here is a example of BCD addition. So they have done the sum of 184 plus 576. You have to add it with the procedures of a BCD addition. Okay, so see how they have written the number 184. So the number 1 is represented with the 4-bit code, and the number 8 is represented with the 4-bit code, and the number 4 is 4-bit code. Okay, so the number 1, 8 and 4 are represented with its 4-bit BCD equivalent. So that is written. Same way for 5, 7, 6, the 4-bit binary equivalent of BCD equivalent of 5, 7 and 6 is written. Then we'll do the binary sum. Okay, so do it for each digit we have to do. Say for example, first we need to add 0100 and 0110. So this part, these two you need to add. Okay, so this and this. Okay, so you will be adding and you will get the sum as 1010, right? 1010 stands for 10. It represents a 10. Okay, that it comes under this third case. That is, it is a greater than 9 category. Okay, so if it is greater than 9, what you have to do, you have to correct it. You have to add a 6. 0110 is added to the binary sum again. And after adding a 6, what you get is a valid sum and a valid carry. Okay, so once only you will be adding a 6, only one time. Okay, to correct the sum, only one time you will add a 6, that is 0110 to the incorrect result. And once you added a 6, then the resulting sum and the resulting carry is a valid sum and a valid carry. Okay, so whatever the sum you get, you keep it here, and if the carry is generated, you keep it for the next set of addition. Okay, so this is taken here, 1. And do the same, repeat the same procedure for this digits addition also. Okay, so this is how we need to do the BCD addition, and the problems are already discussed to you. Now, based on this input, we'll understand the circuit for the BCD adder. BCD adder can also be asked in your question as a decimal adder. Okay, both are one and the same. Okay, so here you can see this table, right? The binary sum, you can see this table. Okay, so in this table, we have used the variables like k, z8, z4, z2, and z1. So why this z8, z4, z2, z1 means it is a BCD sum. So BCD is called as a 8421 code, right? So based on its weights, we are representing it as Z8, Z4, Z2, and Z1. And K, let it be the input carry. Okay, so this is the inputs that is based on which the table is drawn. And can you identify how many values are there present in this table? How many values are there in this table? Students respond. You have written the values as your friend said. So the sum, possible sum can be from 0 to 19. Okay, so 0, this is a 1, this is a 2, a 3. Okay, so this will be up to 9. Okay, etc. up to 9. And then you may have from 10 to 19. Okay, and the 0 to 9 is a valid sum, and if you get otherwise after 9 any values you get from 10 to 19, it is said to be the invalid sum. Okay, so how do we construct a circuit for this, so that we'll understand. So here we have used two set of 4-bit adder. 4-bit binary adder will do addition of 4 bits. Addend and augend will be of 4 bits each. Okay, so here we have used two set of binary adders. Here you can see it, right? So you will be first that adder will do the initial addition. Okay, so that is this one. Okay, so you will do the initial addition, right? The binary addition. Okay, so to produce this result, I'll be using the first adder, that is a 4-bit binary adder, and that adder will produce a sum as Z8, Z4. Let me, it will be producing 4-bit sum, right? So I have named the 4 bits as Z8, Z4, Z2, and Z1. Okay, and the further one more adder is there, and you can understand the purpose of that also. Yes, if suppose it is an incorrect sum, then I need to correct it by adding a 6, right? Then to perform this addition, okay, I need another adder. So the second 4-bit adder, binary adder, is also used based on the values produced, that for Z8, Z4, Z2, and Z1. Is it visible to you clearly? I'll zoom it. Okay, so this 4-bit adder will produce the values as Z8, Z4, Z2, and Z1. We'll be checking whether the result is a valid or not. If it produces the binary values in the range of 0 to 9, it is valid. No need to do anything. Okay, it is a correct sum. Suppose if it is 10 to 19 means we need to correct it, and to correct it we have the circuitry here. You may see a circuitry which has two AND gates and OR gates here, right? I'll explain you how this circuit works and what is the idea for the correction. Okay, so how we know that manually that if we know to do that if it is in the range of 10 to the resulting sum is greater than 9, or if it produces a carry and all, it is invalid. We need to add a 6. We know to do it manually. But how could we design a circuit for this? This logic I'll make you understand now. Okay, so the initial set of addition is done now, and it produced the results of the sum bits as Z8, Z4, Z2, and Z1, right now. Then what we'll be doing here is I'll make you explain this. I'll choose a, okay. So we need to identify the conditions for the incorrect sum. Okay? Incorrect sum. So what are all the incorrect sum? Just a minute. Okay. So if the k bit, that is if a carry is produced, okay, that is the last 4 cases, right, ma? If the carry is produced, okay, it is incorrect. Okay, so this OR gate circuitry will accept one of the input as carry. Okay, so if suppose the carry is a 1, okay, then it will be given whatever this OR gate, no, it may receive either a 0 or a 1 as a input. Okay, suppose carry is produced as 0 means this OR gate will be given the input as 0. If it is 1 means the same 1 will be given as input to the OR gate. Okay, so this one case invalid case is addressed now. Okay, if carry is produced, it is invalid, right? So I'm explaining you what is this circuit doing. Okay, let us talk about the other cases. Okay, so what is this AND gates doing? Okay, see in this 10 to about 10, if suppose Z8 and Z2 is a 1. Okay, let us underline those cases. Z8 and Z2 is a 1. Okay, so Z8 and Z2 is a 1. Here also Z8 and Z2 is a 1. Okay, so in those cases also invalid, right? So to this AND gate you see Z8 and Z2. Okay, so Z8 this is and Z2. Okay, so you can give this Z8 bit as input and Z2 bit as an input. Okay, if both are containing 1, say if I am having a 1010 here in the sum, assume that you are having a 1010 in the sum. Okay, so Z8 bit is a 1, Z2 bit is also a 1. So if I give the AND gate inputs as both 1 and a 1, it will produce a 1 as output, right? Yes. So in that case, the OR gate will receive a 1 as a input. Okay. So let us discuss about the other case. What is the other case possible? Is Z8 and Z4 together. Z8 and Z4 together. Okay, these two cases. Okay, Z8 and Z4 is a 1. That is also invalid. Here we are going to feed the circuitry. Okay, so to add a 6, how it have to work. So that is the idea of this AND and OR gates involved. Okay, suppose if I take the digits that is to be, let us take it as a 1100. Let me take it sum resulting sum is 1100. This is invalid, right? 1100 stands for a 12. 12 is not a valid BCD, so we need to add a 6, right? So 1100 means Z8 and Z4 our bits are 1. So that bits will be given to the AND gate here. So when both the inputs are 1 to the AND gate, the output will also be a 1. This is, I'm explaining you different cases. Okay, so this is a one case and this is another case. Okay, so when the AND gate is producing a 1, that output is given to the input of OR gate, right? What is the natural functioning of the OR gate? If any one of the input to the OR gate is a 1, the output of the OR gate will be a 1, right? So the OR gate will be producing 1 as output. This is a circuit for to correct the sum, to identify whether the sum is a valid sum or not. Okay, so these two AND gates and OR gates are working for that purpose. Okay, so either if I get the carry as a 1, okay, so either if you get the carry as a 1, okay, or if you get Z8, Z2 bits as a 1, or if you get Z8 and Z4 bits as a 1, all those are invalid cases. Okay, so in either of the 3 cases, either carry is produced or Z8, Z4 bits together is a 1, or Z8 and Z2 bits together it's a 1. That is denoting the conditions after 10. After 10, that is 10 to 11, those numbers, no, that is what differentiated by using these 3 cases. The carry is produced in the red color highlighted points. Okay, carry is produced for 16, 17, 18 and 19, the binary values. Okay, so though the sum you see, the sum is lesser than 9. Okay, but it is producing a carry. Okay, this is an invalid case that is given here. And Z8, Z4 together it is a 1 and Z8, Z2 is a 1. Those also invalid. Okay. Okay, I've explained you by taking the two inputs, two various set of inputs. Suppose the sum produced is 1010, then it is indicating a 10, right? 10 is not a valid BCD, so we need to add a 6. Okay, so this Z in this 10, Z8 and Z2 is a 1, right, ma? So when you give Z8 and Z2 together as a 1, okay, so that is said to be invalid. Okay, so in that case, the OR gate will be producing 1 as output. Same way, I have taken the second example. Suppose if the resulting sum is 1100, where the first two bits is a 1, that is also an invalid result. So Z8 and Z4 is given to the AND gate, and the resulting the OR gate result will be a 1. If any of the input to the OR gate is a 1, either of the three cases, it will be passing a 1. See where this 1 is getting passed. So the circuit is designed beautifully. See where the 1 is passed. The 1, here I have another set of adder, right, to add a 6 to the sum, right? So that 4 bits of sum, right? So is that 8, Z4, Z2 and Z1 is given as one of the number to the second set of 4-bit binary adder. Okay, so to this we are adding a 1. So that the resulting 1, no, out of that OR gate, okay, so that will be passed here. And the first and 4 bits, no, it will be set as 0. Okay, and the one that is output from the OR gate will be passed as an input here. So which is made as 6. So the sum is added with the 6, and the resulting S8, S4, S2 and S1 is a valid sum, and the carry that is produced is a valid carry. Okay, suppose if I take this values as suppose the resulting sum, if let me take the resulting sum here, I'll write as 1000. Okay, 1000 stands for 8, right? We have told about in which case 6 is added. Let us take the other case, that is valid sum is produced. Z8, Z4, okay, Z2, Z1. Okay, I'll be erasing the other contents. Suppose the sum that is produced, first stage of addition, the sum produced is 1000. Okay, so in this case, neither the carry is produced, it is 0. So this OR gate will get a 0 as input. And Z8 is 1, Z4 is 0. So the AND gate, when one of the input to the AND gate is a 0, the output of the AND gate is a 0. And when you give Z8 and Z2, Z8 is a 1, Z2 is a 0. When one of the input to the AND gate is a 0, the output is a 0. So when all the inputs to the OR gate is a 0, I'll get a 0 as the output of the OR gate. Then 0 will be passed here, right? So instead of adding a 6, I'll be adding the sum with a 0. What does that mean? The sum will not be changed. Okay, anything added with a 0, the sum will not be changed, right? So that is what you need to understand. Okay, so this circuitry will work. This part, okay, it is working to identify whether the produced sum is a right one or not. Okay, so if I give the valid result, then this Z8, Z4, Z8, Z2 AND gates and all will produce the 0 in outputs for me. And no carry is also produced, right? I'm adding 4 bits numbers, and I'm getting a sum of 4 bits. So no carry is produced. So carry is also 0. The output of this AND gate is also 0, and the output of this AND gate is also 0. So the OR gate will be producing 0 as output. Okay, so if at least one of the condition, invalid condition is there, true means if at least one of the input to the AND gate is a 1, okay, OR gate. If any one of the input to the OR gate is a 1, the output will be 1. You know the logical function of the OR gate already. Okay, so this is how the BCD adder works. So for this 9 cases, okay, so nothing will be changed. That is, here in the second set of adder, you will be simply adding it with a 0. That means that no change will be there in that resulting sum. This sum and this sum will be the same. Okay, so the 10 to 19 case only, to handle that, we have this circuitry. Okay, so if carry is produced, or if Z8 and Z2 bits together, it is a 1 in these cases, or when Z8 and Z4 bits is a 1. Okay, so those are all invalid, right? So you add a 6. So that is the output of the OR gate will be a 1. That will be fed to this. So which will add a 6. Okay, instead of 0, 0, 0, 0, you will add 0110 to correct it. Okay, so that is all with the BCD adder. Students, do you have any doubt in this? Whether it is understood, whether the concept is understood?
Yes, ma'am.
Yes, ma'am.
Okay, okay. Thank you, ma'am. Thank you all the students for the active participation in the activity, and hope